Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a reaction and a commentary to an article from one of the friends of the channel, from Sleepy Fox. One of his posts has just blew up, so he's having a bit of an internet moment, which reminds me of my internet moment that I had a few years ago when I published an article called The Case for Tinkering, which had very little to do with software. It had mostly to do with hardware and the transition from PCs, which are modular, to boxes that you cannot modify. And this was posted on Hacker News and it kind of blew up, but it went down in a few days. It was just, I had, I don't know, 3,000 comments in 24 hours or something like that. And many of them I lost in a migration. So in honor of this, I thought, okay, let's look at, and because Sleepy Fox is also a very deep thinker, from my opinion, I like to take some time to look into this article. And the article is entitled Fox's Laws of Software Development, which should be fun. It's called a not entirely serious treatise, so it's not meant to be fully serious, but let's see, because I know he has some very interesting experiences. He's been through a lot of companies, a lot of contexts, and there are few things that he can talk about. So when he manages to kind of distill some of these, it's really interesting. Over the years, I've observed that software development is less a science and more an art. There are, however, certain laws of nature that it does well to understand and not try to defy, as bad things happen. Fox's first law of software development: small teams. And this is the law. Any program that can be made in a reasonable period of time by a team of 10 or fewer programmers. If that is not the case, then either A, it cannot be built, e.g. depends on some other thing that doesn't exist yet, or B, you have the wrong 10 programmers. This was inspired by the experience I documented here, net negative producers. Over the years, I've seen it play out again and again. A small team of capable professionals left to get on with it the way that they know best, do what tens or hundreds cannot. This is the common thread throughout all of the attendees' experiences at Snowbird in 2001 that led to the formation of the Manifesto for Agile Software Development. This is also one of the reasons why, if you discuss with many of the core Agilists, they will tell you that you cannot scale Agile, because basically what you're trying to do, the key in Agile is to work with small teams. And how do you scale that? How do you scale basically magic, if we were to exaggerate a little bit? But it's really a context in which people work well together. They are interested in the project. They know how to build it. They have the freedom to do what they want to do. So a bunch of things need to happen to get here, and it's not necessarily certifying people in Scrum or things like that. So let's look a little bit on net negative producers. This is a bit of an aside, but I looked over this article and it looks really interesting. So, net negative producer. How on earth could a set-top box app software development team, basically a simple Linux UI app to parse a program and stream some videos, have 20 people on it when surely 4 or 5 should be more than enough, a friend asked. In answer, I told him the story of when I started on an assignment for Hutchinson 3G in their new posh glass building in Maidenhead, working in the new 3G products division in early 2002, producing what were essentially a bunch of web apps. I asked my boss now how many people were working on the project. 350 was his reply. My jaw dropped onto the floor. Don't worry, he said with a smile on his face. All the real work is being done by 9 guys working in a back room of the pub over the road. This new glass building is just a decoy to confuse Vodafone and Orange. So if this is true, that's really funny. How on earth could it possibly take 350 people, DBAs, product managers, project managers? Okay, Sleepy Fox, you have a bit of a of an error here. Hero product manager twice. Architects, BAs, QAs, developers to produce a bunch of simple web apps. I simply couldn't get my head around what I had assumed would be perhaps 25-30 people at most. Talking about microservices, am I right? This was a pattern that was to repeat itself, and it took me a while to understand why. Back in my early days in the IT industry, I assumed that experience and productivity were related by a linear function, like productivity equals experience times a constant, let's call it A, giving us P equals AX. This implies that if a developer has twice as much experience, then he would be twice as productive, more or less. The following diagram shows what I mean. And it's basically a line. Productivity versus experience, productivity increases linearly. And of course, this is wrong. I mean, first of all, there's a problem with experience. If you are experienced in the same things, in doing the same things over and over again, your experience has not grown in software development. You have just done the same thing again and again and again. So, this is the first thing. Then there are phases in a developer's life. It's very difficult to keep things simple. And sometimes what you will do, and I was guilty of this as well, is figure out some interesting but complicated solution and really want to implement that. And so productivity goes down. It's basically is not a line, right? It can go up and down depending on what you're doing. Yes, even then I understood that there is a difference between experience and skill, as 5 years of experience could mean 5 years of constant learning and improvement, or 1 year of learning followed by 4 years of repeating the same things over and over. Yeah, that's what I mean. It took a few years more before the true scale of what was going on became apparent. Good developers with twice as much experience were not twice as productive. They were perhaps 4 or more times as productive. The relationship between experience and perhaps ability and productivity wasn't linear. It was more like a power law. P equals A power X. This looks more like the following diagram, and it's basically a power curve increasing. Yeah, so the thing here is, okay, if we define experience as year of constant learning and improvement, maybe, but let's see. As it turns out, there has been plenty written about this from Steve McConnell, yeah. The research that shows great programmers are 20-25 better than mediocre one, to Mark Zuckerberg's famous quote that someone who is exceptional in the role is not just a little better than someone who is pretty good, they are 100 times better. So this isn't exactly new news. People debate this in the IT industry back and forth all the time, but I've noticed that the people who are great developers or who are managers or executives who have worked with great developers simply take it as an empirical fact, and it only ever gets debated by people who haven't actually experienced the phenomenon or who have actually read the research. It did, however, take a few more years for the real penny to drop, and that is that for the graph I had drawn in my head, the function does not pass through the origin, and instead of P equals A power X, the function is more like P equals A power X minus B. So we can start with negative productivity. Okay. I have a few comments, but let's first go through this. The end result of this is that the poor developers who are swimming in the shallow end of the gene pool are not just poorly performing, they are net negative producers. What does this mean? This means that the programmers to the left side of the graph are the ones producing the bugs that the people in the middle portion of the graph are fixing. They are the ones inserting misleading comment, writing spaghetti code, implementing poor design that the developers further to the right are wasting time fixing, deleting, refactoring, and redesigning. If your organization doesn't have many people in the far right hand side of the graph, then it is easy to see that no matter how many developers you have, you might not be making any forward progress at all, although you'll be burning a ton of cash. I've illustrated this with some shading below. It's basically, shading underneath the curve to show how the left and the right side cancel each other. Thus, you need more people to the right of the blue section in order to outweigh the net negatives. If you don't have many people on the right-hand side of where we cross the x-axis, then the reason for the lack of progress becomes obvious. It is this graph that explains the original question. How can you have so many developers and yet be accomplishing so little? The inflection point on the graph of where productivity crosses the x-axis, where a programmer becomes a net positive producer, are now referred to as the MVP, minimum viable programmer. All right. So now this topic is a pretty hard topic. And the reason is that it's hard to talk about it without creating emotional responses from programmers. I think because this domain is so complex, we are all worried that we might not be doing as well as we think. And sometimes, for some of us, we were lucky, like for me, because I really loved programming and I love spending a lot of time thinking about code and writing about code and so on. But if you got into this job just in order to get some money, which I'm not judging, that's fine. I mean, it's been one of the jobs that allows you to get here for money. You might feel like you are an imposter, basically. And the imposter syndrome is, I think, is much more spread out in the developer community than it is actually expressed. The reason being, once again, it's a difficult domain. It requires a lot of attention. You need to be very careful. You need to be able to collaborate, but at the same time, focus for long periods of time. There are many things that are difficult. And so, because of this, whenever we talk about differences between programmers, between individual programmers, we might end up thinking, okay, why don't we just get these programmers and remove everybody else? And that's also against my core beliefs as a coach, because what I believe is that actually we can grow people and we can find their proper place in teams, because every person is valuable, every individual is valuable. So when I see something like this, one possible thing that people might say is, okay, how about we just get the best programmers, leave everybody else, ignore them and so on. But I think there's something to be said about teams as well. And building a team where you have the necessary skills and they kind of fit together, it's not only about these individual programmers. Okay, there may be people in the team that are not writing a lot of code, but that are actually bringing the team together. And because of this, there are a lot of different dynamics. in the teams. And so please don't interpret this as we only need programmers, we only need the best programmers and forget about everybody else. Instead, you need to really think and deeply think about, okay, what technical skills do we need in the team, but also what can we do to kind of bring everybody together on the same track, because that's the other part of the magic. It's not only people who know how to solve problems and perhaps solve them much quicker and without introducing a lot of issues, but it's also about how can we make these people who may be individualistic in nature work together and discuss and communicate. And so there's more to that. We cannot simplify it. This kind of thinking works if you have individual programmers or very small teams. And anyway, due to the market, you won't be able to get like the 25 times programmers, most likely. So yeah. And there are other jobs, other roles that can help teams kind of get better. Okay, but I have seen this in practice, on the other hand. I mean, I've seen people who are not very good at programming. They were trying, but they were actually bringing the team down, and we had to work after them to fix. My answer has always been in that situation, let's try to find them a better role, a role that makes them happier, that also fits them, their skills, their knowledge better. There's value in them understanding programming, there's value in them understanding how programmers think and work and so on, but perhaps actually writing code, maybe they need some help, maybe they need some practices, maybe they need to be more of a support kind of role. Okay. Corollary. As yet another example of how pretty much every idea I've ever had has already been thought up by somebody cleverer, I found an example of prior art on War Cunningham's wiki, referencing work by G. Gordon Schulmeyer in his own words. We've known since the early 60s but have never come to grips with the implications that there are net negative producing programmers on almost all projects, so insert enough spoilage to exceed the value of their production. So it is important to make the bold statement, taking a poor performer of the team can often be more productive than adding a good one. Yeah, I've seen this also. That's true. Or changing the role. That's usually better. This is why in 2011 a major household name came to the company I was working for and asked us why with more than 120 offshore Java developers on a project they couldn't make any progress. Answer, as harsh as it may sound, employ professionals that can actually do the job. The famous well firefighter said when a potential customer blanched upon being told how expensive his rates were, if you think it's expensive to hire a professional to do the job, wait until you hire an amateur. I read that there. Yeah. So this is harsh. This is true, but it's important to interpret the consequences adequately. That's one thing I like you to live with. But in general, smaller developer teams that know what they are doing, that want to do that job, that are interested, that can work together well, that's the best place to be. Now, how do you get there? It's a whole other question. Fox's second law of software development, difference between theory and practice. There is only one difference between theory and practice. That is that in theory there is no difference between theory and practice, but in practice there is. We've all seen them. They walk in and pronounce with great confidence that because the theory of MVPs states that because you shouldn't build a thing unless there is a proven need for it, Yagni, that you shouldn't have built logging in your solution pre-launch. Really? This is an actual example I had for an architect on a project. Really? Oh boy. Until what? Until it had broken down and our customers were clamoring to know why? I've built many systems and there is never one that didn't need logging. You are going to need it because practice trumps theory. Yeah. Uh, I mean, this is silly. And I think, okay, there has been this push from Agile to kind of build smaller things and to really consider the things that are needed. But when we think about the things that are needed, these are not only the things that are needed for end users, but it's also the things that are needed for the other, let's say, stakeholders, for the other users, for admins, for programmers, for testers. These are all things that need to be in the system. All right. Now, you could do experiments, but that's a different thing. That's not an MVP. And I would actually like to see more experiments. For example, you could create a small feature, deploy it either separate from your application or as part of your application, give access only to a limited number of people, maybe at first only to internal users, and then you can go and give access to friendly external users, people who you know won't try to hack your system, and you know, and even just in case, you know, keep it kind of separate from the rest. And if you do that, this is a proof that users either want that feature or that users don't want that feature. Or it might be something that's unclear. And in that case, you need to do another experiment. So, and if once you do that, you then go and implement it according to the architecture things. It's still an MVP, but it's proven because the feature has been shown to be useful through an experiment, but then it gets into the MVP. But the MVP needs logging, the MVP needs security, the MVP needs monitoring. You need all of these things, well, depending on, and at different levels, actually, depending on how many users you actually have. Right? If you have 100 users, probably don't need a lot of scaling and thinking about all that stuff, but you definitely need security. Because there will be people who are trying scripts on your URLs and on your endpoints. So yeah, you do need that. You do need logging because when something goes wrong, you need to be able to fix it relatively quickly. You need to put in things like localization because it's very difficult to put them later on. Well, depending on technology, but for some of them, at least it used to be quite complicated to add them later on. So it's best to add this from the beginning because it's just a very simple thing to do if you do it from the beginning. There are multiple things that you need to do from the beginning, and those are part of the MVP. It's clear. Yeah. But the point here is not really this. The point is that practice trumps theory. So if you've seen something in practice, in your past practice that helped, do that. No, And there's really power in this empirical style. We need to think empirically about and to learn, because every context is different. And so things that we have learned in a specific context may not translate very well to another context, but you'd better be careful with reapplying them in your context, because they might actually be good. So knowing that you will have problems, you will need logs to debug, definitely something to do. That's a general thing. There are not many best practices in software development, but having logging, one of them. Fox's third law of software development, metrics. Giving a manager a metric is like monkeys juggling chainsaws. Whilst initially it might seem impressive, it always ends badly. I could write a book about this one. Thankfully, several other people already have, so you are spared my terrible writing. From Deming's Out of the Crisis, to Muller's The Tyranny of Metrics, to Kuhn's The Case Against Standardized Testing, to Taleb's Fooled by Randomness. The reality is that hardly anyone has the background to understand numbers, but we try and manage using them based upon highly simplistic and inaccurate models of systems. This very often leads to poor results. A better option is to use management by walking around. Go to the Gemba, see what is going on, ask the people doing the work what is happening, and give them the authority and budget to fix things. Another word for this is leadership. Deming, Drucker, Ono, Hock, Goldratt, many have talked about this. Yes, and we had a whole conversation about metrics when I think it was McKinsey that launched a metrics system for software development, and we saw that it's not as simple as they are saying. And basically, I agree here, because numbers are actually very difficult. They can be made to look nice, but they can also show the wrong things very easily. So you have to be extremely careful with this. So management by working around, or go to the Gemba as used in Toyota production system. This is my recommendation for managers. Just go every day, do the tours, ask people what they are doing, what challenges they are facing, and fix as many of those immediately, and that's it. Give them the money, give them the time, give them budget, authority. And reinforce this message, okay? When there is a specific problem, please fix it. This is how you can fix it, so on. Fox's fourth law of software development, greenfield projects. There are no greenfield projects. Really good. Every project is a brownfield project. Even when you have no legacy code, you have legacy experiences, legacy worldviews, a legacy boss, legacy expectations, and legacy trauma. I like this term, legacy trauma. And I think we'll talk a little bit about it. Even the stuff you learn from on the interwebs is somebody else's legacy. Legacy trauma probably deserves an explanation. All developers with time served have experiences in their past they cannot bear to repeat. These form patterns of aversion that, when triggered, cause powerful effects. Unfortunately, the human brain is a first fit rather than a best fit pattern matching engine, and false positives abound. Yeah. So I've seen this again and again. Legacy trauma. People living in very difficult conditions. Like at some point, this was a funny one. Somebody was telling me, I think it was at one of the unit testing or test-driven development learning programs. And he was telling me that we had somebody in the team who ran the test, showed, the tests are running, so everything is working fine. And then we pushed we started the application and it didn't work. And this really matches one thing that I keep telling people at unit testing, test-driven development. You need to start the application from time to time because all of your tests can be passing, and I'm showing them how. All the tests might be passing, but you forgot to configure something for production, which is not tested because you cannot or not easily. And it doesn't work in production. And it's basically a line of code or a line of configuration. But this was an argument, it was a trauma. Because this happened, it means that this practice doesn't work. And it's not true. What is true is that every practice has an applicability domain. Every practice will work up to a certain level, and then depending on it might be larger or smaller, but you need to know where the limits are for every practice, and you need to know that whenever you go beyond those, it stops working. It's as easy as that. There's nothing that works 100% of the time, well, except logs. You should have logs. So because of this, and I see this again and again and again, developers fall into this trap of saying, yeah, this didn't work for that particular case, even though that particular case is outside the domain of applicability for that practice, and therefore it doesn't work. That's not true. You just need to learn what the applicability domain is, apply the practice where it fits, don't apply it outside of the domain. So these are things that I've seen, and this is just a small example of legacy trauma, but you can see much more examples. People writing code in a certain way, avoiding certain design patterns because at some point people have overused design patterns and the code was incomprehensible. So on, so many things. Fox's fifth law of software development, employee turnover. When it's easier for your employees to find a new job than it is to get a promotion at their current job, your company is on the inevitable path to no longer being a small fish in a big pond or even a big fish in a small pond, but rather a small fish in a big fish. Acquisition, the discovery that you're no longer a big fish in a small pond or even a small fish in a big pond, but a small fish in a big fish. Corollary to the fifth law, the second order derivative of headcount is the leading indicator of organizational failure in either direction. So, second order derivative of headcount. First order is how many people you had per unit. Second order is, boy, it's hard to do maths. So turnover. I'm gonna skip this. It's hard to parse. Folks, sixth law of software development, remote. If anyone is remote, everyone is remote. This is simple empathy and respect for people. If you're having a meeting and one person is remote but the others are all on site, then everybody should individually be on video conferencing to make it a level playing field. Yeah. And this is how you should be organizing meetings if you are in a mixed environment, because otherwise it's very difficult for people to join. Fox's seventh law of software development, K8S. Really a variant of Gonwi's law. Given long enough or tech discussions turn into discussions about K8S. I think K8S is Kubernetes, right? If you are an infrastructure as a service provider, then perhaps Kubernetes is relevant for you. For the rest of us, there are simpler options. It behooves us as professionals to always use the simplest thing that might possibly work. yeah, dep packages, um, snap packages, virtual machines. There are a lot of things that you can do. Fox's eighth law of software development, internet publishing. If you need to get something that was originally published on the internet, the chance of it being retrievable is proportional to 1 over 2 to time, despite of some people would have you believe that is stuff on the internet has a half-life. That's true, and that's true because of a few things. One of them is disappearing websites. The other one is old formats that you cannot read anymore. If you are interested in this, research a bit archival and the challenges that the web archive is facing. This is particularly difficult with old document formats and other file formats, but it can also be difficult with things like games, which don't run anymore on specific things, or no, Flash. Where can you run? There was a time when every site had a Flash version, and or it seemed like it. And now we don't have Flash anymore. So if you want to see a website, an older website, or maybe the content was published as Flash, good luck. I have no idea how you could do that today. And that's a large part of the internet being erased by technological progress. Corollary to the eighth law, if you need something not to be available on the internet, it will persist indefinitely despite all attempts to remove it. E.g. that GeoCity site you made in 1995. That is funny. Fox's ninth law of software development, 2 hard problems. There are 2 hard problems in computer science. People are the hardest problem in computer science. Convincing people that people are the hardest problem in computer science. This is a bit recursive. I like it. And indeed, what we notice is that most of the difficult problems, and where we have most bugs in software, is not really in the core areas like collections and sorting algorithms and encryption algorithms, and those are, because they are very technical, there's some mathematics involved. You can compute, you can review, but try doing something with date time and with calendars, or with anything that touches, real life of people. That's when the trouble starts. That's really where things are complicated. Okay, so these are the Fox's 9th laws of software development. I think I would add, I have a few observations regarding to how things evolve in a product. So I have a law that I keep repeating, which is 1 will be more. And the example would be if a product manager or a user or a client comes to you and say, just implement this financial software for euros because we'll never need a second currency. You can bet that in 6 months, 1 year, 2 years, 3 years, somewhere in the lifetime of this product, if it's successful, you'll get the request to implement the second currency. And this one will be applies to more things than just currency. It can apply for every type of thing where you think they are telling you it's only 1, it's likely there will be more. Another thing that happens is that constants will turn into variables, will turn into formulas. So something that is in your code a constant, and you believe it's a constant, will eventually become a variable because somebody we'll need to be able to change it. And if things go for long enough, it will become a formula because it's something that you compute based on something else, probably other constants that go the same way eventually. So, but these are more like things, laws of product evolution, laws of evolution of design, kind of, because they influence how you design your software. So yeah, these are some things that are, let's say, more technical in nature, but they are still related with people in the sense that these things happen because the world around the product is evolving, or the world around the product is more complex than we initially thought it was, or the part of the world that we want to cover with our product expands in other domains, and so this is how it expands. And these are good things to remember when you are designing your software and you think, this will just be a constant, just leave it as a constant. Maybe it's good to have functions instead sometimes, or have it stored in a database anyway, because who knows. All right. So these are some of the Fox's laws and my commentary on it. I think these are very interesting, and as he said, it's not entirely serious, but I think he touches on a bunch of things that are really interesting. So thank you, Sleepy Fox, for writing this thing. And have fun. I know you are at Socrates UK. I wish I were there. Have fun there. And for all of you, what do you think about these laws? Let us know in the comments. Are there things that you agree with, that you disagree with? Things that you have seen that are not part of it? Things that you have read that are corollary to this? Let us know in the comments. We love comments. So thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday.